Hello, my name is Adil Rasool, and in this video I'm going to discuss about quantization of charge. Let's get started. Quantization of charge simply states that the existence of charge is in discrete packets rather than as continuous amount, which simply means that the charges has got the grainy nature. Likewise, we can count the grains of rice, the grains of wheat. Similarly, we can count the number of charges on any charged body. In simpler words, quantization is that property by virtue of which a charged body or any charged body can have a charge which is an integral multiple of basic or the elementary charge. That is, we can write Q is equal to plus minus n times E, where n is the integer value and E is elementary charge. Elementary charge is nothing but it is the smallest charge, which is the charge of either electron or the charge of proton, whose value is equal to 1.6 into 10 to the power minus 19 coulomb. Now let's understand this concept at the microscopic level. As we know from the famous theory of Dalton known as Dalton's atomic theory, according to him, the atom is the smallest and the indivisible particle of matter. But on further discoveries, we found that atom is no more the elementary or the fundamental particle, but it's itself made up of the constant particles, namely electrons, protons, and neutrons. While protons and neutrons are present in the nucleus of an atom known as nucleons, and electrons are present in the shells of an atom. Similarly, on further discoveries, we found that the nucleons are no more fundamental or the constant or the elementary particles, but they are itself made up of the constant particles, namely quarks. Now let's understand about the quarks. So quarks are simply the elementary particles having the fractional charges, and they combine together to form the composite particles called hadrons. The most stable of them are protons and neutrons. We have basically 6 types of quarks. One is up quark with a charge of plus 2 by 3, down quark with a charge of minus 1 by 3, charm quark with a charge of plus 2 by 3, strange quark with a charge of minus 1 by 3, top quark with a charge of plus 2 by 3, then bottom quark with a charge of minus 1 by 3, where E is the elementary charge or the basic charge. We have got their anti-quarks also, like anti-up quark, anti-down quark, anti-charm quark, etc. So we can analyze here that these quarks have got fractional charges. So does it mean that it's violating the law of quantization of charge, which states every charged body should have a charge which is an integral multiple of elementary or the basic charge? Does it violate? No, it doesn't, because the quarks have got a property called color confinement property. Due to this color confinement property, these quarks does not exist in isolation or they does not exist in the free state. So let's understand that how they exist in the combined state. When 2 up quark and 1 down quark combine together, they form a particle called proton. So if I add up their charges, suppose up quark has got a charge of plus 2 by 3, again next up quark has got a charge of plus 2 by 3, and then down quark has got a charge of minus 1 by 3. If we add up them, we'll get a charge which is 1 times E, which is nothing but the charge of proton, which again holds good according to the law of quantization of charge. Similarly, when two down quark and 1 up quark combine together to form a particle called a neutron. So if we add up their charges, one down quark has got charge of minus 1 by 3, and another down quark has got a charge of minus 1 by 3, and one up quark has got a charge of plus 2 by 3. So if we add up these charges, we'll get the charge of 0e, which is nothing but again the charge of neutron. So therefore we concluded from these 2 examples that the law of quantization holds good at the microscopic level too. So that's all about today's topic. Thank you so much.